Velocity space explained simply. There are three words: here, now, and stationary, which each apply to space, time, and velocity space, respectively. There's a place in space called here, which we think of as arbitrary because it isn't really a specific place in space. Here could potentially be any point in space, even there. Here is just wherever you happen to be in space. 1 kilometer is the length of a line in space, and it is also a specific distance between two different points in space. Velocity, meanwhile, is a change in spatial coordinates over time. Of course, this is all very obvious. Moving on. There is a moment in time called now, which we also think of as arbitrary, because it isn't really any specific moment. Now could potentially be any moment in time, even then. Now is just whenever you happen to be in time. 1 hour is the length of a line in time. It is a specific distance between two different points in time. Aging is a change in the temporal coordinates over time. Now, there are some interesting questions and caveats that I could go into here with respect to what I've just said, but it is better if I continue along with this line of thought. Everything that I've said so far is very obvious and not even slightly controversial, but I'm really just trying to get across the profoundly important but basic concept of velocity space. Moving along. There is a point in velocity space called stationary, which we think of as arbitrary because it isn't really any specific velocity. Stationary could potentially be any point in velocity space, even one that is moving. Stationary is just wherever you happen to be in velocity space. 100 kilometers per hour is the length of a line in velocity space. It is a specific distance between 2 points in velocity space. Acceleration is a change in velocity space coordinates over time. So here is about spatial coordinates. Now is about temporal coordinates. And stationary is about velocity space coordinates, of which there are 3. And there's 1 coordinate of time and also 3 coordinates of space. That is all you really need to know to correctly understand and apply the concept of velocity space. Unfortunately, whenever I tell physicists about this new concept, which they are unfamiliar with, they often assume that I must have some specific, sophisticated, and abstract concept in mind, like the other types of spaces that they're used to working with, such as configuration space, or Hilbert space, or phase space. Velocity space is nothing like these conventional types of spaces. It is ironic, but velocity space is actually too simple and too obvious for most physicists to grasp. Believe it or not, it took me about 3 days worth of dialogue to explain this very simple concept to a particularly famous Nobel Prize-winning physicist who many of you already know by name. Simple as it is, velocity space is really the missing puzzle piece that you need if you want to understand theoretical physics, and especially relativity. You might ask, why would such a simple concept be so disruptive now and so important? And the answer, I think, is that because it has been absent and neglected by so many experts for such a long time. Hopefully, the tide will start to turn soon enough.